Okay, we are going to go over section 2.1, rectangular coordinates and graphs. If you look at your paper, you will see that we are only going to cover examples 2, 5, and 7. Let's look at these blanks here that we need to fill in, and you can follow along with me in your ebook if you would like. The x-axis and y-axis together make up a rectangular coordinate system. So let's fill in these blanks. Rectangular coordinate system. Or another name that we use is Cartesian coordinate system. The plane into which the coordinate system is introduced is the coordinate plane. Or better known as the XY plane. The x-axis and y-axis divide the plane into 4 regions, or we also call them quadrants. If you draw a rectangular coordinate plane, remember the horizontal line is always your x-axis, the vertical line is always your y-axis. If I were to break this up into quadrants, the upper right is quadrant 1, and then we want to go counterclockwise. This would be quadrant 2, quadrant 3, and quadrant 4. Now the first thing we're going to look at with this rectangular coordinate system is the distance formula. If we had 2 points, P and R, and remember the x coordinate always comes before the y, so this would be the x and y from the first point. That's why it's called x1, y1. These are subscripts, not superscripts. And then this is the x and y value of the second point, so therefore it's called x2 and y2. If we are given these 2 points and we want to find the distance between these 2 points, the formula for that is the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's look at an example of how we can figure out the distance. Let's look at this example. Find the distance between the points negative 8, 4 and 3, negative 2. The distance between P and Q would be the square root of x2 minus x1. Well, this is the x from the second point, so this is our x2. This is the x from our first point, so that is x1. Now notice the formula is always minus, so be careful if x1 is negative. We're going to have minus a negative. So we have 3 minus negative 8 squared plus, this is our y2 value because it's the second point and it's the y value. This is our y1 because it's the first point y value. y2 minus y1 squared. Now remember your order of operations. Please excuse my dear Aunt Sally. P is for parentheses, so we need to do what's inside the parentheses first. 3 minus a negative 8 becomes 3 plus 8. So we have the square root of 3 plus 8, which is 11 squared, plus negative 2 minus 4, which is negative 6 squared. Now the next thing in the order of operations is, please excuse, E is exponents, so we need to do the exponents next. The square root is going to be the last thing that we do. So let's square 11. 11 squared is 121. Negative 6 squared is 36. Now at this point in the problem, you should always be adding 2 positive numbers. It does not matter if the number up here is positive or negative. Once we square it, we should get a positive number. So we should be adding 2 positive numbers together. The square root of 121 plus 36 becomes the square root of 157. Now we need to see, if possible, if we can reduce the square root of 157, if we can simplify this. We cannot, because there is not a factor of 157 that is also a perfect square. Therefore, this is the answer, the square root of 157. Okay, let's move on to the next example. The midpoint formula. Again, if you'll look in your book, you can follow along with me. The midpoint between 2 points. So think about this. First of all, midpoint. Our answer is going to be a point, an ordered pair. And I want the middle value between these 2 points. When we think about middle, you think about average. So if we find the middle value of these 2 points, I can find the average of the x's and the average of the y's. So x1 plus x2 divided by 2, that's how we find an average. Add them together, divide by the numbers that you're adding together. And then the same thing, we can find the average of our y's, y1 plus y2 divided by 2. Notice again, the midpoint is a ordered pair, not just one number. So let's fill in these blanks. That is, the x-coordinate of the midpoint of a line segment is the average of the x-coordinates. And the y-coordinate is also the average of the y-coordinates of the segment's endpoints. So let's look at an example here. Again, we have point 1 and point 2. So if you wanted to label your numbers, this would be x1, y1. This would be x2, y2. Finding the midpoint of these 2 points would be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Well, let's simplify this. 8 plus 6 is 14. Negative 4 plus 1 is negative 3. We can simplify 14 over 2 to be 7. However, we cannot simplify negative 3 over 2. We could change this to a mixed fraction, but in math and algebra, we normally just leave our answer as an improper fraction. So the final answer is going to be 7 negative 3/2. Again, this is a point, an ordered pair, midway between these 2 points. So this is our answer. Let's look at the next example. Find the coordinates of the other endpoint Q of a segment with one endpoint negative 612 and midpoint 8 negative 2. So this problem is giving us the midpoint, wanting us to find one of the 2 points. So again, midpoint equals x1 plus x2. We'll let Q be x1 and y1. P is going to be our x2, y2. So x1, we're trying to find out what that is, plus x2, which is negative 6, divided by 2. y1 plus y2 divided by 2. And then they're telling me that this should equal 8 negative 2. 8 negative 2. So let's see how we can figure this out. I know that this should be 8. So I'm going to set up that equation. x1 plus negative 6 divided by 2 equals 8. If I solve this equation, I can figure out what x1 is. Well, we can just cross multiply here to get rid of the fraction. If you wanted to, you could put that over 1. So now you see x1 plus negative 6 times 1 is just x1 plus negative 6. I'm going to change that to be x1 minus 6. Same thing, just looks a little neater. 2 times 8 is 16. Now to solve for x1, all I need to do is move my 6 to the other side. Remember, anytime we move it to the other side, we need to change the sign. So this is going to be x1 equals 16 plus 6. So x1 equals 22. So I have the x value of my point Q that I'm trying to find. Now let's find the y value. Again, let's set this y1 plus 12 over 2 equal to negative 2. And then we're going to do this the exact same way we just did the other one. You can put the 2 over 1, cross multiply, y1 plus 12 times 1 is just y1 plus 12. 2 times negative 2, negative 4. Subtract 12 from both sides, negative 4 minus 12. So y1 equals negative 16. Now I need to put these together to form my point Q. So the answer is Q is, remember the x value always comes first, 22, negative 16. That is our answer for Q. Okay? Now let's look at how to graph these equations. And you see some steps here, graphing an equation by point plotting. The first thing we want to do is find the intercepts. Well, let's talk about intercepts. What are intercepts? There's an x-intercept and there's a y-intercept. Once we have our graph down here, you will be able to tell the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. To find those intercepts, let's just write that down here. To find x-intercept, you let y be 0. To find y-intercept, you let x be 0. Okay? Now, a lot of times 2 points is not enough to graph. So we might need to find a third or even a fourth ordered pair in order to graph. Then once we get our ordered pairs, we plot the ordered pairs, join the points with either a smooth line or a curve. So let's do that for this first one. The equation is y equals 4x minus 1. Okay, well let's do a table of values. We can let x or y be anything we want. But it says to find at least 3 ordered pairs, and I want 2 of those to be the intercepts. So let's first let y equal 0. If I let y equal 0, that means right here I need to plug a 0 in. 0 equals 4x minus 1. Well, let's solve this for x. Bring the 1 over, divide by 4. X equals 1/4. So when y is 0, x is 1/4. This is the x-intercept. When y is 0, this is the x-intercept. Let's find the y-intercept by letting x be 0. Okay? This time we want to plug in 0 for x. So we have y equals 4 times 0 minus 1. That's going to give me 0 minus 1, or simply negative 1. Now, to find a third ordered pair, I can let x or y be anything I want, other than something I already have here. Since my equation is solved for y, it might be easier if I plug in a number for x. So any number other than 1/4 or 0. So let's just pick x equal 2. Let's see what that gives us. Let x equal 2. Y equals 4 times 2 minus 1. 4 times 2 is 8 minus 1 is 7. So when x is 2, y is 7. Now let's plot these points. 1/4, 0. Well, there's not a 1/4 up here, so you just have to kind of guesstimate. You know it's between 0 and a half, so about right here is 1/4. y is 0, so I'm actually going to be on the x-axis. So there's my point 1/4, 0. Now I need the point 0, negative 1. X is 0, y is negative 1. So this time we are on the y-axis. Now x is 2, y is 7. So there's that point. Hopefully you can see that when I draw a line between these points, it will just give me a straight line. So let's do that. So here is my line. Notice I put arrows. That means the line keeps going forever and ever. That will be important in sections to come. Now let's look at B. Y equals the square root of x minus 1. Again, I'm going to plug in numbers for x and y. But this one's not going to be as easy. Notice I have a square root. Anytime you have a square root, you have to stop and think. Remember, we cannot have a negative underneath the square root, or it's going to give us an imaginary number, nor can a square root equal a negative number. So y cannot be negative, and what's underneath the square root cannot be negative. Well, think about this. What is the smallest number that x can be so that what's underneath the radical will not give us a negative number? If I let x be 0, like I did over here, I had let x be 0 in one of my positions. If I let x be 0, I get 0 minus 1, that's negative 1. That's not going to work. So x is not going to be 0. If x is not 0, that means we're not going to have a y-intercept in this equation. Well, what's the next number? If I let x be 1, let's see what that gives us. If I let x be 1, I'm going to get y equals the square root of 1 minus 1. Well, that gives me the square root of 0, which is just 0. So when x is 1, y is 0. Y is 0, that tells me this is the x-intercept. You can see that 1 is the smallest number that I will be able to use. Anything less than 1, I'm going to get a negative. So when I plug in numbers, I need to plug in anything greater than 1. Well, let's let x be 2. If I let x be 2, I get y equals the square root of 2 minus 1. 2 minus 1 is just 1. The square root of 1 is 1. So when x is 2, y is 1. Now, you might think, well, let's let x be 3 next. Well, if I have a square root, I kind of want to be choosy of what I'll let my x be. If I let x be 3, I get 3 minus 1, which is 2. The square root of 2 does not give me a nice whole number. So what is the next x that I could get that would give me a square root of a good number so that when I take the square root of that number, I get a whole number? Well, I know the square root of 4 is 2. So what should x be if I want to make this 4? You probably guessed it, x should be 5. And I'll show you that. If I let x be 5, y equals the square root of 5 minus 1. 5 minus 1 is 4. The square root of 4 is 2. So when x is 5, y is 2. Now let's plot these points. 1, 0, 2, 1, 5, 2. Hopefully you can see that this is not going to give you a straight line. It actually looks like this. Notice also it does not cross the y-axis, like I said, so therefore it does not have a y-intercept. Now, I want to show you something else. Anytime in the entire course of college algebra, if you are asked to graph, and your equation is y equals, you can graph these on your calculator. So get out your graphing calculator. I'm going to show you how to do this. If you have anything there, go over and clear it. Okay, the first one we had was 4x minus 1. So under y1 equals, let's type 4x minus 1. 4, anytime you need an x, here's your x button. It says xt theta n. Just hit that and you get an x minus 1. Now be careful, make sure you do not hit this button. This is negative. This one is your minus. So 4x minus 1. Now just hit graph. And you will see that you have the exact line that we showed on our paper on A. But you can hit y equals again, go over and clear that. Now let's do the square root of x minus 1. To get the square root, you'd hit second, the x squared button. Now some of you are going to have a parentheses that opens. If the parentheses opens, you're going to have to close it. If you do not see a parentheses and your square root is over your cursor, then you will not need a parentheses. So just know that your calculator may look a little different. Now just type x minus 1. In my case, I do have to close the parentheses and then hit graph. Again, you will see the exact function that we just graphed in B. I'm going to stop this video so that it's not too long, and we'll pick up with example 7C.